So hi everybody, I'm Ethan Zindler. I'm with BloombergNEF. We are a division of Bloomberg that does energy market research on the energy transition globally with a focus on really the trend towards decarbonization. And among the technologies that we, and the sectors that we think about are industry and decarbonizing industry. So it's really my pleasure to be here today to chat with this outstanding panel. To give you guys just a little bit of background, and I know that we have some people in this room who are practitioners and know a lot about this space, but I'm going to assume that many don't, including many hundreds who I understand are listening in online as well. For some background, industrial emissions, which is emissions from the production of materials such as iron, steel, and cement, represent really one of the greatest and most difficult challenges to reducing CO2 emissions longer term. Between them, all those three represent about 10% of global emissions. And to vastly oversimplify what the challenge is, the production of those materials require a tremendous amount of energy and a tremendous amount of heat. And as a result, they are not easy to decarbonize. But if we are going to actually get to zero emissions or something close to it, obviously these are thorny sectors that really need to be addressed. So I'm really pleased today to have a great panel that is ultimately, I think, going to solve the problem for us collectively. I think I want to structure the conversation really around three things. First, I want to hear about the technologies, and we really have the experts here to talk about that. Second, we probably want to talk a little bit about the policies. Should I take this off now, or should I keep it on?
Please leave that on, and I'll take it. That's yours.
How's that? Okay. Sorry, everybody. So we're going to really structure the conversation, I think, in three ways. One, I want to talk a bit about the technologies, and I think we have a great panel here to do that. Two, I want to talk about the policy drivers that are creating some of the change that we're seeing. And three, I do want to talk a little bit about this region specifically and some of the opportunities that are here and opportunities to come. So I believe everybody should have biographies of these folks either on the paper in front of you or online. So I'm not going to read the great details. Would you mind turning me down a little bit? I feel like I'm feeding back in my own ear here. But immediately to my left is Dr. Alexander Fleischanderl, who's the head of green steel at Primetals Technologies. And to his left is Andy Purvis, who's the director of sustainable manufacturing at the World Steel Association. We have Magali Anderson, who's the Chief Sustainability and Innovation Officer at Holcim. And finally, down the end, we have Emmanouil Kakaras, who's the Executive Vice President of Next Energy Business at Mitsubishi Heavy Industries. And maybe I'll start down at the end, and if you could, Emmanouil, if we could start with you, talk a little bit about some of the technologies that you guys are pursuing at Next in terms of thinking about the decarbonization of steel production.
Thank you very much. It's quite a challenge to talk and be heard, one, because of the mic. Thank you. Second, to talk in such a nice panel, very highly skilled and competent participants. But I will say that the technologies to decarbonize the hard-to-abate sectors are known to us. And the message is clear and loud and accepted by everybody. It is either end-of-pipe carbon capture, storage, and to a certain extent reuse and utilization, or decarbonizing the energy mix to get rid of what we call indirect CO2 emissions. You mentioned yourself that this is an energy-intensive process that we're talking about. In that context, I think renewables at a maximum possible extent and subsequently hydrogen will make the way to decarbonization. And the second point to that is that we need no further technology development in the sense that we don't lack the invention or the silver bullet to go to carbon-free 2050. We have the technology portfolio. around these two main vectors that I mentioned, and we would like to see it happening at scale. We need to de-risk, we need to go boldly into large-scale projects to pave the way, and everything else will follow.
So actually, I think I said I was going to go down the line, but I want to... I would like to hand it to Alexander, because we're going to talk about, I think, steel first, and then we'll come to you, Magali, afterwards. So tell us a little bit about Primetals and where the role that you're playing in decarbonizing steel.
Basically, Primetals is a global player as a technology supplier in the iron and steel sector. And what just Emmanouil started is true also for the steel sector. Over the past 12 months, clearly the technologies have evolved. So it's pretty clear now the pathways we will go for decarbonization. And these are just three pathways. One is electrification route, and that addresses clearly to remelt scrap at the end, which is limited in the market, so there's an undersupply. That's not the ultimate solution. The second one is direct reduction. Reducing iron ore with natural gas for the time being, as long as natural hydrogen is not available at scale and at a reasonable price. And finally, carbon capture and utilization. So these are the three pathways. And this is the large progress we have done over the past 12 months. There was clear uncertainty at the last COP which way to go. And now most of the steel companies have set their roadmap how to decarbonize. And that's a good thing.
Mm-hmm. Andy, I think that kind of tees you up maybe to talk a little bit about what some of the commitments are that we've seen and some of the ambitions. And then I do want to come back ultimately on those three pathways and talk about what some of the advantages and challenges are of them. But first, Andy, your thoughts.
Thanks. I think it's an interesting time for steel. And I guess if I just reflect on where we are in terms of this journey, you know, just walking around this place, steel makes all of these things possible. The decarbonization, the renewables, the infrastructure, you know, and it's great for the circular economy as well in terms of recycling and reuse. But I think in the past maybe that's where our industry stopped talking, and that was the end of the conversation. But we're not there now, and I think there's a very clear understanding that we need to decarbonize the emissions from our sector, and we need to reduce. And I think there is a pathway to do that. One is around efficiency right now, to make sure every ton of steel we make now is made as efficiently as we can be. The second vector is around scrap. We need to use every ton of scrap we can, but scrap's limited. It's a function of the past. The third step is decarbonizing emissions through breakthrough technology, and that's really the conversation I think we need to have around. I agree the technology solutions are clear. The question now is around deployment at scale. First demonstration at industrial scale, and then deployment. That, I think, is the policy challenge that we're facing globally at the moment. We need these technologies. We need to learn from operating them.
So Magali, yes, we're surrounded by steel, but I have no doubt we're also probably sitting on some cement at the moment as well. Tell us a little bit about the thinking and the processes right now around decarbonizing cement production.
Yes, good morning everybody. Very happy to be here with my steel colleagues and representing cement. So first of all, I would like to rephrase something. I never call myself being part of the hard-to-abate sector. I always call myself being part of the full of opportunities sector.
I like the
Because
optimism.
when we do our net zero pledge, as we did with our target validated by SBTi, the impact this is going to have is enormous. So much opportunities, fantastic, right? So, but to go into a little bit of technical details, that's what you are asking. So, do I have the time of the three people for me? Or so, to go to technical details, to make cement, you have to heat up a kiln or a big oven, if you will, to 1,400 degrees. Contrary to my colleagues here, I have something I can do myself to replace my fossil fuel, is I can use waste. I can use city waste and all kind of waste, and I can completely replace my fossil fuel, which represents 30% of CO2. I already have plants that goes at almost 100% replacement, and it's a great lever. And then what comes out of that oven is called clinker, and you will use that clinker to do cement. And this is where we will talk about the clinker factor. So our current clinker factor at Holcim is 70%, and we want to reduce it at the lower clinkers, the less. And what I use there, I use byproduct from my colleagues on the panel here who give me all their slag that they have in their process to put in my cement. But unfortunately, because of their own roadmaps, they will have less and less slag. So I'm working on all kind of novel minerals that will be able to reduce my, my clinker factor to a certain level. So this will take us to our 2030 roadmap, again, which is validated by SBTi. Past 2030, we will need CCUS. And I think here, I will not go further here, but I think the CCUS is the same that you guys have, which is really technology exists. A few plants are already doing it, but scalability, economic feasibility, et cetera, will be the challenge of the next 4 or 5 years to come.
So if I'm hearing you right, there's a pretty clear path to some decent incremental reduction between now and the short run. But if you want to get to zero, it's going to be some additional technology that comes along, or one of these applications of these existing technologies that we're talking about.
So I think it's a mix of both. One is, as it was expressed just before by Emmanouil, is really how do you scale it up? How do you make it, because we'll talk about policies after, how do you have the right policies to scale it up? But I'm also in charge of innovation, and we shouldn't completely disregard the possibility of an innovation coming up to disrupt all of that and make us accelerate. But in our current roadmap, we didn't want to bet too much on innovation, because that would have been greenwashing. That would have been, I'll wait for that magic innovation to come up and then I will go to zero. Mm-hmm. So that would be greenwashing.
Let's talk a little bit about hydrogen versus CCUS, and I realize I'll frame it as a versus question, but you guys can correct me if I'm wrong. Maybe Alexander, first with you, talk a little bit about sort of the comparative advantages and disadvantages of the two, and then certainly welcome Manuel and Andy, and of course Magali as well. But within the context of steel production first, both are technologies that have not been fully deployed at any massive scale yet. So what are the potential challenges around both of those?
Well, first of all, I would say competition is a good thing. If we talk of competition between hydrogen and CCUS, competition accelerates the technology pathway, and that's what we need. I think both technologies come compulsory, so we need both, as has been addressed before. Well, with hydrogen, steel is utilizing hydrogen already today. So when we talk about natural gas, we talk about steam methane reforming, which ends up at a pretty high share of hydrogen in the reforming gas. So the technology works. The technology is not the limit. It's now really the switching from natural gas midterm and gradually to green and blue hydrogen sources. So I don't see any limitation there. Finally, for CCS, it's required for steel. Steel comes always with carbon. And by the way, just to give a bit of context here for the figures, 70% of the steel today is produced based on fossil fuels, on coal steel. So, while we will reduce it year by year, the amount of coal that is going to be used to produce the steel, there are new assets in the market in India, Southeast Asia, and China as well. So we have a large number of blast furnaces that are based on coal. These assets costs a fortune. Yeah? So there's billions of dollars in these assets. So switching and leaving these assets stranded is not an option. So for these assets, definitely the best way is to implement CCS on the midterm.
Manuel, first, do you agree with that? And second, if hydrogen is a technology that's as viable as Alexander's saying, why hasn't there been more done so far?
How could I disagree with Alex, first of all? Second, I have to confess the convenient truth. I'm a great fan of hydrogen. I have spent all my research years doing research on hydrogen because of my academia background. But I don't believe that we will have as much hydrogen as we need or we will need to get us to 2050 carbon neutrality or even earlier. That being the case, is inevitable that you will use end-of-pipe sequestration, storage of CO2 to abate the emissions that will be kind of residual emissions. Because even if we had all this hydrogen that we would need, we cannot, for instance, expect that by 2040 everybody will flying a hydrogen plane or something like that. So, on top of that, I have to say that we are coming from Mitsubishi Heavy, where we have leadership in both fields. So we have leadership in CCUS, and we have leadership in hydrogen use, for instance, in the gas turbines. And we are not schizophrenic to pursue mutually contradicting technologies. We see the complementarity. Alex explained that we feel that CCUS is a kind of enabling technology, avoiding the stranded assets, permitting investment decisions to be taken today with the long view that is needed for the investments we are talking about. And we see also the need for decarbonization coming both from electrons, roll out renewable electricity, have abundant renewable means, moving to green hydrogen, but also from molecules. And molecules can be either green or blue hydrogen molecules on the other side, on the one side, and stored, sequestrated, stored CO2 molecules on the other side. So both needed, and I don't think that we will do one without the other.
Andy, to you, does the steel industry have a preference? It strikes me that hydrogen might be a technology that can be sort of more used within the fence line, so to speak, versus CCUS, where you're more contingent on a partner, although I'm sure partnerships are required in both cases. But is there a sort of a directional pull in one way or the other?
I mean, I live in Europe, and I think Europeans could, or looking at Europe, you could be forgiven for thinking hydrogen is the answer. And for all the reasons I think that have been talked about, it's always dangerous to go third, right, because everything's been said. I agree entirely, we need both, and we will use both. Different regions and the technologies that will be applied in different regions will very much reflect the local conditions. That's policy conditions and resource conditions. You look at Europe, most of the steel makers in Europe, in fact, have made the choice to go to hydrogen. That doesn't solve the problem in India, and it doesn't solve the problem in China. And probably I'm more concerned about CCS as a technology. I see lots of noise around hydrogen. I think there's a hydrogen summit happening in this building today. CCS is one of those technologies that is vital, but it always seems to fail to be delivered at scale. The Europeans have had a go at it. There's some initiatives now in the US. CCS concerns me most. We need cost-effective technologies, but we need infrastructure. And for me, that is the biggest challenge with deploying CCUS at scale.
Yeah.
You can expect steel companies, I think, reasonably, to invest in capture, to look after their own emissions, but you need then to take that somewhere and store it safely and reliably.
Yeah.
And we are not there yet.
So yeah, speaking of white elephants or stranded assets, we have some in the United States related to CCS and coal-fired power for sure. Magali, to you, it's a similar set of questions, though. You know, as you think about it, it sounds like you're in some ways a little less further down the line in terms of thinking about which technology and may be more open. But you tell me, are both in play equally?
So if tomorrow morning you bring me a bunch of green hydrogen at the door of my plant, I could definitely use it to replace fossil fuel, but I actually think it would be a waste of good hydrogen, because I think there's so many sectors that have no other choice than using hydrogen to decarbonize, that using it to replace our fossil fuel when we can already do it by replacing waste wouldn't really make sense, I think. However, again, if tomorrow you come to my door with a nice pricely green hydrogen, I would be very happy to use it. Hydrogen will definitely come in use for our CCUS projects. And I agree with what was said just before. The CCS problem is not so much the capture. We have more than 30 pilots ongoing in about the equivalent number of plants. And capturing, we are not too worried about it, even though a cement plant, give or take, is about 1 million tons of CO2. So that's what we are talking about in terms of scale of capture you need to do. But what do you do with that hydrogen becomes a complexity. Storage cases, great cases, the quickest way to get rid of it. Where is the infrastructure, where is the reservoir compared to your plant, etc., needs to be sorted out. And if there is not a mega infrastructure deployment, it's going to be very complicated. Utilization, there's two things about it. There is a legislation part of who gets the credit and so on, which is not that straightforward yet. But also how to utilize it at scale. But you know, you were talking about planes flying with hydrogen. We have a project that got a big fund from the EU Innovation Fund of capturing our CO2 in Germany. It's a plant called Westküste 100, where we will, using hydrogen, we will transform that first in methanol, then in kerosene to do SAF, to do synthetic fuel. So CO2, we need to start thinking of it as a resource and no more as a waste, as something that can be useful to help decarbonizing other industries. So our CO2 helps someone else to decarbonize.
Interesting points. Before we move on to policy, actually, I did want to address one thing which I feel like is sort of a giant player that's not in the room, and is that we have no representation from China on this panel, and that I think that's no fault of anybody's, given how difficult it is, sadly, to have our Chinese colleagues participate in conversations like this right now. But Andy, I did want to get your sort of quick thoughts on where members of your organization are in terms of thinking about this from the China perspective, given the enormous amount of production that takes place there.
I do think there's still a perception in the world somehow that Chinese steel is dirty or inefficient, and if you get nothing else from this panel, please take away that it isn't. The assets in use in China are probably, if not the newest in the world, up there. They have ultra strict air emission requirements. So Chinese technology right now is probably leading edge. I do believe we are seeing, I mean, we've got members in China. Most of the larger sort of state-owned enterprises are members of Worldsteel. And if I look at what they're up to, there's been certainly a big change. And I think, and the Chinese government set a target of net zero by 2060, and that really prompted action from the steel makers. And in fact, most of them have set targets for 2050. So if I look at just two examples, Baowu and HBIS, I think they're number 1 and number 2 in the world at the moment in terms of production. They have both got net zero targets for 2050. They are both investing heavily in first-of-a-kind demonstration plants. HBIS are building a 1.2 million ton DRI plant with turnover. Baowu are also investing both in hydrogen and in CCS. So certainly China it's a terribly important place, given half of global steel is manufactured there now. But I certainly see action, and it's the kind of place that I think if there's a will to do something, it'll happen. So I'm confident that the Chinese industry will increasingly move forward on this topic.
So that actually sets us up nicely to talk a little bit about policies and the kind of drivers that are possible. I'm based in Washington, D.C. In August, the Inflation Reduction Act, or the IRA or IRA, was passed, and that was a major commitment from the U.S. to focus on CCUS and on hydrogen in a way we've really never seen before. But of course, Europe also has its own types of policy regimes to try and create a market here. Maybe we could start with you, Emmanouil, to talk a little bit about the sort of comparatives between the two regions and sort of the advantages and disadvantages of both in terms of what they're trying to do.
Thank you for starting with me. Although I'm not a policy maker, I'd rather say that I'm a policy user in terms of
Policy taker, okay.
implementing innovation. But this question I have to answer every week when I report to the headquarters of MHI in Japan, because currently there is such a tremendous impulse towards the states and the efficiency of IRA that makes all the initiatives of the European scheme, the Fit for 55 and so on, and as being less efficient. And I wonder myself whether that is true or not. So a couple of thoughts on that. There are a number of ways that policy can be effective. It could affect either the supply of innovation, of new technologies, of de-risking the technologies, or it will affect demand. That means it could influence customers to buy more green products, or the green steel discussion and so on. Now what we are seeing here historically is that in the US the policy was always more supply driven, so de-risking the supply of hydrogen, putting a quote $3 per kilogram on hydrogen, end of story. Whereas in the European scheme, the policy was always a bit on the end user side. And we are having all these regulations, we have all this branding, all the marks and all these things. And if you neglect the supply, it is questionable whether the end user will be finally convinced. First of all, because it is more complex and more structured. The example of the energy prices right now and what repercussions we are witnessing in terms of meeting green targets, it's a very good advance. So as always, the truth is in the middle. That means we definitely need in Europe to have a clear sign on the supply of technologies, de-risking the technologies on the supply side. I think what is done in the Innovation Fund is an excellent example of balancing the subsidy part on CapEx with the support on the OpEx side of a successful project. So I'm quite optimistic for projects on this kind. And on the other hand, in the US stage, I think that looking a little bit more in the demand side will definitely support the rollout of this investment. So as always, we are in the middle, but I think both models can learn from each other, and this is what is currently happening in Europe and in the US.
Yeah, do you want to jump in on that?
I guess I was going to add, yes, policy is critical, and policy will play a number of key roles around many of the topics we talked on this morning about infrastructure, around facilitating partnership among within the ecosystem, but also promoting demand and also facilitating first movers who we really need to succeed to learn some of those lessons. It's clear to me policy will be local or regional, maybe, if we take the EU as a bloc. And I think that we're not in a world of top-down policy anymore in this space. One of the things which I think we need to think about is what happens when these various policy regimes butt up against each other. So we have the EU with their border carbon adjustment mechanism. There is potential for carbon adjustment mechanisms or other policies to develop differently in other regions as they develop their own frameworks. And I think a really important point is going to be, how do we make sure that with all of this mosaic world of policy, that trade is maintained and we maintain free trade. In terms of my material, steel is very well traded, both as products and indeed as semi-finished products intercontinentally. So I think it's really important we start to have a conversation around standards, and we start to have a combination around international standards for low carbon steel. I don't like green steel, but I think I've lost that battle. Since it's Alex's job title. For green steel, so that if you buy a ton of green steel or you want a ton of steel, low carbon steel in Europe, you can buy confidently from the US, from the Middle East, from China, and know that it meets the standards and you won't have issues with import-export. I think that's probably one of the critical points that we need to think about going forward.
Yeah, I think, this energy transition loves colors, so you're not going to win that battle. Magali, you look like you want to add something as well on this in terms of, and I think it was an interesting framing that Manuel set up for sort of supply versus demand. I would even put it in cruder terms, which is a carrot or a stick kind of approach that we're seeing on different sides of the Atlantic. But which do you think is better, or which is the most, I would say, advantageous as you think about your long-term goals of decarbonization?
Well, I won't repeat what was said in terms of policy and why it's needed and why it's a great accelerator, but because today we are not necessarily being incentivized to decarbonize, which sounds a bit silly when everyone talks about it, but when you go into the details, you are being incentivized in different ways with CO2 pricing, but then with all the requirement of keeping a level playing field, and this is where CBAM that you just mentioned comes in field. So. But I would take maybe a different angles. I think I like your bottom-up mention because I think there's sometimes the policy can make a great change, but as a company we shouldn't be waiting for policies. I think if the movement comes from us as well, it will make a great change. And the example I will give here is when we launch our EcoPact, which is our green concrete. So the definition of EcoPact is 30% less CO2 than the standard concrete. We launched it 2 years ago. Everyone told us there's no market for it because there's no requirement. There's no legal framework asking for it. There is no requirement for public tenders to require lower carbon products via, for example, EPD, Environmental Product Declaration. So you guys are launching something that no one is going to buy. And there is a moment between the chicken and the egg. You just have to decide to do it, right? If not, the discussion can last forever. 2 years later, this famous EcoPact represents 15% of our global sales, which is incredible. I mean, when is the last time you guys launched a product that represented 15% of your sales in less than 2 years? So I think the companies need to do their part, and that sends a very strong signal also to the legislator that they need to do their part and we can work together. So I'm not sure I answered your question, but I just wanted to give a third angle to it.
It's well taken. Alexander, anything else to add on policy, or do we want to move to the Middle East?
Just quickly to add, I think all correct what have been said by the colleagues. Actually, the policy is important to kick off projects, and that what having happened over the past 12 months. So now, if we see the demand side, it's interesting, and no one believed that the demand side is really requesting decarbonized steel. So now I avoid the color. Yeah? But there's a strong undersupply of decarbonized steel in the market, which is good because that's creating a premium, and the premium pays for the business case. And there are certain projects in the market where we talk about a certain premium in the range of 30%, even 40%. And I think that's the important thing also Emmanouil was stressing out. We need this demand side driven approach. Yeah.
Great. Okay, so we've got about 15 minutes, and I think we want to have a few questions. So let's talk for just a couple minutes, though, before we go about questions about this region that we're in today and what some of the opportunities are here. I'll start with a basic assertion, which is compared to the United States and the EU, there's not the same kind of policy supports in place at the moment to support green materials production here. But does that make this a less attractive market to develop these kinds of projects, or are there other things that come into play?
No, so actually it's a fantastic place to develop such decarbonization projects, because you have to know, well, if we talk about steel, it's extremely energy intensive. So about 70 to 80% of the cost to produce steel is related to the energy. So well, if we talk about the perspective of cheap renewable energy, about blue or green hydrogen in this region, I think it makes it simply attractive to expand the business for direct reduction plants or even pig iron, so green steel plants in this region. And it's important to know when we talk about low carbon steel as or hot briquetted iron from a direct reduction plant, about 50% of the world production is coming from the Middle East today. So we should not ignore that. So the Middle East is already playing quite a significant role when we talk about decarbonized green metallics.
Well, go ahead, Andy.
I was just going to add on that. I think this region is really important. I often assess where's important in the steel world where my boss goes. He spent a lot of time in India before the pandemic. Recent months he's been here in the Kingdom, in the Emirates. As long as I've been in this industry, just building on what Alex said, people have been asking the question, why do we ship rocks around the world? Which we do in vast amounts. Why don't we ship metal? Because we just ship effectively waste that we melt and use to make cement and throw away. It's still there, but I think the discussion that we're having now is for different reasons. We're going to see potentially the shift to making HBI or hydrogen or cleaner iron in regions like this with an excess of energy, or regions with an excess of energy, and or like Australia are looking at this space. It's, I think it's really exciting. The potential for growth in the Middle East in terms of capacity is big, both to export, but also in terms of investment. I mean, I was looking at the line and other potential investments and projects within this region. I think there'll also be a big growth in demand for iron and steel, and indeed cement and concrete, as some of the infrastructure goes in, as this region starts to transition away from the fossil fuels and more to a more sustainable future. So I think this is a tremendously exciting part of the world to be in from a steel and a decarb perspective.
Magali, are you similarly optimistic?
I'm always optimistic.
Okay.
And this region has a key role to play in energy transition, we all know that. But even when it comes to green product, even though we fully understand the challenges, we fully understand that the legislation is not there, but think about it. We talked about CBAM earlier. So hopefully soon there will be border mechanism.
Just interrupt, the carbon border adjustment mechanism with the EU program. Okay.
So there will be soon an adjustment, which means that zero CO2 products coming to Europe will be without tax versus the ones with CO2 will have a lot of tax. So think about the production of cement in this, or clinker, I should say, more than cement, going across the Mediterranean. What's the business potential there as soon as CBAM is in place? So I know MENA is full of super business people. That's the type of thing that they can think of to decarbonize here. And if the legislation has not evolved on time, you can always send it somewhere else. So there is all kind of way to think, and I really trust the smart people of the MENA region to find those business cases that maybe are not helped yet by the legislation.
Manuel, any quick last thoughts on MENA before we take some questions?
Yes. First of all, we know that the region has a brand, and the brand is energy. So it's an energy exporting region, and I think the carbon neutrality will not jeopardize this advantage. I think equally the region will be an energy exporter of green or carbon-free molecules because simply the region is also blessed with a huge renewables potential. Having said that, the second characteristic of this region is that it hosts energy-intensive industry. Allow me for a second to take the glory of steel towards aluminium, which is a little bit neglected in this discussion, but it is equally energy intensive or even more. It has more than 80% indirect CO2 emissions, so decarbonizing the energy supply of alumina plant, as we are recently announced with the new technologies, is a must for the region. So the region is hosting these initiatives, and most interestingly, for the first time globally, in this region we are launching an exercise even to decarbonize the direct emissions from an alumina smelters. In practical terms, dealing with CO2 concentrations below 1%, which is a challenge in technical terms. And why this is happening in that region is because the region will continue to host energy-intensive industries, and because of the carbon border, these energy-intensive industries will produce green products in the region. And I have to say something because you commented the speed in policy making. I think in the region very recently we see some bold moves in the CO2 management and the creation of a CO2 storage infrastructure, which will make the difference and will definitely accelerate the production of carbon-free products in the wider sense, fuels, steel, alumina, using also the possibility to store and effectively manage CO2 in that region. This is something we have to give credit to the policymakers of the region as well.
Great. Okay. Questions from the audience? I see a couple hands. Does someone have a mic? Okay.
Thank you very much. My name is Said Ibrahim from Steel Egypt.
Could you speak up just a little bit? We're having a little trouble hearing you up here.
This is not working.
We can hear you, but you got to speak loudly, please.
Okay. My name is Said Ibrahim from Steel Egypt. Andrew said that it is an interesting time for steel industry. I think it is a very difficult time for this industry at the moment because, you know, green steels means that we are going to be intensive use of hydrogen. And according to the current technologies available, the cost of having hydrogen is very or pretty high. So imagine the cost of producing ton of steel. Some studies say that it's going to be doubled at the moment. So who's going to afford these prices at that time? This is from the economic of hydrogen. On the other side, when we are talking about technology, yes, green hydrogen definitely means that direct reduction implementation. And having hydrogen means that we are going to have low carbon or no carbon at all in the direct reduced iron or sponge iron, which means that on the other side of the industry and the steel making, unless there's gonna be a breakthrough in the technology of electric arc furnace, this industry will be at risk because, as you know, of course, that carbon in the DRI is much more effective than adding the carbon to the electric arc furnace.
Could you ask that as a question, please, so that the audience...
The question is that if we don't have a breakthrough technology in the chain of steel making, which means that electric arc furnace, having green hydrogen will have limited effect in the carbon emission because we are going to have more carbon in the electric arc furnace, in addition to the economic of the producing hydrogen for the direct reduction.
Did I get a response to that comment?
Maybe I'll take that. Fully agree. Even I think we should discuss this after the session, as this is about details in metallurgy. But basically, it's true. But see it in this way. If you start with natural gas, and natural gas is available massively in that region, so this decarbonizes already about 60% if you compare it to the baseline of a blast furnace and converter steel making route. This is a good starting point. And it still allows to gradually switch to hydrogen when hydrogen is available and at a competitive price. And it does not mean to switch to 100% decarbonized hydrogen, maybe to stay at 80% hydrogen, still having some carbon in the HBI to allow proper operation of the electric arc furnace. I think this is all well known. And if you start with the natural gas, still there's the possibility, even in that region, that you add carbon capture and capture the remaining CO2 from the direct production utilizing natural gas. So I think the technology is there, and also the business case is there, and still waiting for a couple of years till the hydrogen is available at a reasonable price.
Anybody else? Okay, next question. Anybody else?
Hello, I'm Ali Kushawi from Aziz Steel. For carbon capture and utilization, for the steel industry, we are speaking about from 0.7 to 2.2 tons per ton of crude steel. So this is an enormous amount of CO2. How we are going to use and utilize this amount?
Good question. Do you guys, Andy, you want to jump in?
We're not. There's no, I mean, you're quite right. We're a 2 billion ton industry. We generate at the moment, probably an average close to 4 billion tons of CO2 a year. We're not going to utilize all of that CO2. If we're going to use CCS on some of it in the future, there will be an absolute need for storage. I do think CCUS has a role, utilization, probably more transitional, in terms of it enables potential development of infrastructure, of networks, and provides a potential value and a revenue source for first movers. I think if we move further down the line, it's clear there's going to be a glut of CO2 available. If the cement industry are capturing CO2, we are capturing CO2. There'll be way more, I think, that a market can usefully purchase. But in the transition, I think potentially that technology can play a very useful role in particularly rewarding first movers.
But isn't that sort of getting at it, I think what Magali was saying earlier, which is that you need to think of CO2 as a potential useful product in some kind of way, given that you presumably can't put all of it underground necessarily.
Now there are several usages of CO2. I mentioned synthetic fuel. I could mention synthetic plastic, which is a plant in Austria doing. We use CO2 for greenhouse growing of plants in Spain. Some of our CO2 is turned into minerals. But I fully agree with Andy that there is a scalability issue. So we can do it with a few cement plants. If every cement plant in the world and every steel plant in the world start capturing, it's going to be a bit complex to utilize it all.
Just a brief comment on that. Completely agreed. First of all, there is no question that the rollout of decarbonization will happen only if we all agree that we have to permanently store CO2 because the quantities are huge and they cannot be met by any recycling or utilization scheme. Having that in mind, I think, of course, methanol is a very good example of an easy bridging technology, using that as a fuel without a massive change on the infrastructure. We have seen initiatives in the marine industry, for instance. But I would like to point to you that, especially for this CCU, for the utilization, the origin of carbon plays a role, and we would definitely prefer to utilize biogenic or anthropogenic carbon, not to say carbon from the atmosphere, to create negative credits. So the industrial point source CO2 will predominantly go to storage. There are other sources of carbon that present a better potential for CCU projects, SAF, methanol, name it.
Okay, we have time for, I'm told, literally one more quick question, and then it's going to be real quick answer too. Go ahead, in the back.
Hello everyone, my name is Islam. I'm a nutritionist from UK, but I'm also focused on waste management. And I was wondering if in these materials that are indispensable for construction, have we considered material that is recycled? For instance, according to my research, 40% of the sand can be substituted using coarse sand coming from smashed glass. And the same for the concrete part. We can use shells, like oyster shells, in substitution for a similar percentage for the materials. Are those resolutions a bit greener, and can they also be energy and cost effective in terms of the distances. I come from London. There is a huge consumption of bottles. The bottles are then incinerated most of the time, contributing in an awful way in the carbonization process. I was wondering if these materials could then be used inside, therefore cutting costs for transportation, excavation, digging, and therefore making an inside solution for construction.
So thank you for that question, which is a really interesting one, and it is not a short one to give an answer to, but I would throw it to Magali maybe to try and give a quick one, because I think it's a good question. What about just using different materials?
So when I was talking about the different levers earlier, it's all recycled, right? So today the cement is 24% recycled, which means we, as a company, last year we used 54 million tons of waste, which basically makes us one of the biggest waste treatment company who does cement as a byproduct. But what we are working on, which is even more interesting than that, is what we call construction demolition waste, where basically our vision is you have a building that needs to be destroyed because it's really end of life, you have already renovated it, there's nothing else you can do. You destroy it, and if you use that same material to do the cement that will build it again. And that we already have cement using 20% construction demolition waste inside in Switzerland, which will be deployed in all of Europe because we're working on the norms. The norms will allow it, right? So you're absolutely right. Circular economy, in the cement and concrete industry, is absolutely vital to go on and to help the decarbonization.
Okay, anybody with one last two sentences?
Absolutely, and I think this industrial symbiosis is really important. POSCO are using oyster shells right now in their steelmaking process. I think we gave them an award for that this year. There's a lot of innovative thinking going on around how you can really deploy circular economic thinking.
Last word, unless you want one as well.
To your question, you are coming from the UK, working on the waste. You will hear very soon about technologies recovering hydrogen from waste, which is one more proof that we have to go on the recycling way. Recycling is the low-hanging fruit. And even extreme and very complex cases like the hydrogen production from waste is a promising technology, which is green. And because of that, it is worth looking into that.
Great. Any last words?
Yeah. Last quick statement. So again, related to steel. So for steel, be ensured, not one single ton of steel is wasted. So every ton of steel that is collected at the end of the life cycle is recycled, remelted in electric arc furnaces in the process. That will continue, but unfortunately, due to the capacity of steel that is required, we have to remain also on virgin-based materials.
Wonderful. Well, listen, we just covered a ton of stuff in less than an hour. So please join me in thanking this excellent panel for all their insights. Thank you. Thank you.